All right, algebra guys, let's get started with today's work. We're going to talk about polynomial functions. We're not only going to talk about what they look like and how to arrange them and how to find out what the degree is, but we're also going to be able to evaluate those functions. And really, it sounds more difficult than it really is. The truth of the matter is it's not that big a deal. So here we go. So a polynomial function, remember back when you were kids, a function was, y equals 2x plus 6, and this is a function because it ends up being a straight line, and it has a slope of 2, and it crosses the y-axis at positive 6. But if you started putting in numbers here, you would get a value out. You could evaluate this and figure out what y was. So you created those input-output tables, your x-y tables, and that's what a function is, So they write it in different ways. They either write it as y equals or f of x equals, and I'll still say 2x plus 6. These are exactly the same thing. We're doing the same thing with this. So basically, if I say, okay, well, I want to put in a 1 here. And so I put in a 1, I multiply by 2. 2 plus 6 is 8. So I get out an 8. It's like putting in 1 coin, you get out 8 marbles, etc. It's like a machine. Okay, well, you would do the same thing, only it would be expressed as, hey, what if your function is, if f of x is 2x plus 6, what is f of 1? And so they put the 1 in the parentheses here, and what it says is, wherever you see an x, you're going to input a 1. And so I'll get to that momentarily. You'll still get the 8 out. So I want to go back a little bit and talk about polynomial functions. Yes, 2x plus 6 is a polynomial because it does have 2 terms. But we're talking about those larger polynomials, polynomials with higher degree powers for their exponents. Right now we're going to be talking about polynomials in one variable. One variable just means they have one variable. That's pretty silly, right? Okay, so we're going to be able to find the degree. The degree of a polynomial is easy, so that when they're arranged, in descending order, comma, the degree is the exponent with the greatest magnitude. With the greatest magnitude. And magnitude, that's a fancy word. It just means the highest number. But, you guys are getting ready for chemistry and physics, so you need to know what a magnitude is. All right? And so, for instance, if I had a polynomial function that said, and I'm going to make it super simple here, 4x squared minus 7x to the 5th plus 2x to the 7th plus 5. I would rearrange these so that I go in descending order so that the greatest exponent, or the exponent with the largest magnitude, would be up front. So I put this up first, and we'll put our 2x to the 7th up front. We'll subtract it. We'll subtract from it. This is the second, so 7x to the 5th. X squared comes next, so plus 4x squared, and then we'll just put the constant on the end. And so this polynomial expression, remember it's an expression because there's no equal sign yet, has a degree of 7. So its degree, it's not equals, it has a degree of 7. Sorry about the writing today. Woof! Horrible. And then we also want to look at what is the leading coefficient. The leading coefficient, the coefficient of the lead term, which is 2. So leading coefficient is 2. All right, and so those are the things that we really need to know about these polynomial functions. I'm going to display a little, let me get rid of this, and then we'll go here. And so what are the degree and leading coefficient of this expression right here? And we're going to say, hey, I just need to put it in order. So the largest magnitude exponent is 4, so I'm going to put my minus 2x to the 4th, or negative 2x to the 4th. Then I'm going to add to it x cubed, then 3x squared, then minus 7 or negative 7. And I'm going to say the degree of this polynomial is 4, and my lead coefficient is negative 2. So let's go ahead and try a couple. I'm actually going to switch to Markertown because I don't like the way the pen looks. I want you guys to be able to see this, so we're going to look at this guy right here. This is the first one. Pretty simple, it has 3 terms. So we're going to find the exponent with the greatest magnitude. That's 10x to the 7th, so let's go ahead and write that. 10x to the 7th. We're going to subtract from it 5x cubed, and then add 100. So this is our expression in descending order. So the degree is 7, and the lead coefficient is 10, right? And then we can do the same thing with this. I'm not going to, keep talking about it. I'm going to look up here, and I see that I have an exponent of 8. So I'm going to put up here 8x to the 8th plus 4x to the 6th plus 6x to the 4th minus 10x squared, and we'll put that little constant on the end of 20. And what is my degree? My degree obviously is 8. Oops. I don't know why it's flying away. My degree is 8, and my lead coefficient is also 8. Okay? And so that's the really tough part. Are you good with that? So let's move on. Let's talk about what happens when you have a function. When you actually have a function, and I showed you a little bit earlier, pardon me, a little bit earlier, that if you want to evaluate a function, they will put that number that you plug in for x right inside the parentheses, and then you'll be able to, everywhere you see an x, input that value, then evaluate. All right, so you'll put the -5 here, -5 here, -5 here, and then you'll do the evaluation. All right, so if we put a -5 here, we cube it, we have -125. Put the -5 here, square it, that's 25, times 2 is 50. We'll put the -5 in here, we'll multiply by 10. Minus a -50 is plus 50. So they did all that work for you. And then last, plus 20. And if we do all this math, we end up with -5. I hope that seems reasonable. I'm going to do something a little bit more difficult in a second. Oops, meant to do this. All right, so let's go ahead and evaluate f of 2 for the first one. Actually, f of -5 for the first one. We'll do both, whatever. So this says f of x is x squared minus 9. So let's evaluate if it's f of 2, which means everywhere you see an x, you put in a 2. So f of 2, we could write it as f of 2 equals 2 squared minus 9. We do the math. 4 minus 9 equals -5. So f of 2 equals f of 2 equals -5. All right. I should have written the -5 over here. I apologize. Let's see. Let's go ahead and just erase that, because I don't want you to get used to writing it where I put it. We'll say it's -5. That's us doing the math. We'll leave it as f of 2 equals. And lastly, f of 2 equals -5. Let's leave it like that. That'll work out for us. So let me grab a different color. Oh, everybody hates yellow. But let's go ahead and see what f of -5 is. And we see we have x squared, so we have -5 squared minus 9. So -5 squared is positive 25 minus 9, and we end up with 16. So f of -5, sorry, I'm leaving out the middle one. I just want to keep moving on. F of -5 is 16. So here it's a little bit more difficult. Not super difficult, but I want to show you what this looks like when we start inputting values. So let's go ahead and use something super bright. If you guys don't mind, I'm going to do f of 2, and then just start inputting 4 times 2 cubed. This is very important. I want to talk to you about how to evaluate that. The exponent only refers to the variable, so we would only be cubing the 2 and then multiplying by 4. Write the exponent first and then the multiplication. Minus 3 times 2 squared, and then plus 2 times 2, and plus 1. So if we evaluate this, 2 cubed is 8. 8 times 4 is 32. All right? Again, I'm going to say it out loud again. 2 times 2 to the third power is 2 times 2 times 2, which is 8. And then 8 times 4 is 32. That's how we got there. Okay? The next part, we're going to subtract. 2 squared is 4. 4 times 3 is 12. Next, we have 2 times 2, which is 4, and then plus 1. Now, I'm going to just move from left to right, just because I can do that. I'm allowed. And that's going to be the easiest way. 32 minus 12 is 20 plus 4 plus 1. So f of 2 is 25. And we're all set. Okay. I'm going to skip -5 because I've worked a little long on this, and I think you guys understand this concept. So I'm going to get rid of this. And now I want to talk about this. What if we have another expression, or a polynomial, a variable expression inside, we're going to be evaluating with another expression, right? We're not going to get a numerical answer when we're finished. What we're actually going to get is a different polynomial. And so you see here that they've taken g of x, which is x squared plus 3 minus 4, and they've decided, let's input this guy right here. And everywhere there was an x in the original function, they've put this in there, right? So a squared minus 1 squared, and then you'd have to FOIL it, right? So it would be a squared times, and I'll write it out here, a squared minus 1 squared, and then they did the foiling, so I'll get rid of that square, and then we'll just do a squared minus 1. Well, a squared times a squared is a to the 4th, and then a squared times -1 is negative a squared. -1 times a squared is negative a squared, and then -1 times -1 is positive 1. All right, and so they put these two minus a squareds together, and they get -2 a squared, a to the 4th up front, and plus 1. And that's where this part comes from. All right, the next piece is inputting for x, right? A squared minus 1, and then you're just distributing 3 to it. So we're going to add to it plus 3a squared, and that's what they get here, minus 3, and then minus 4 is the constant back here. So we have plus 1, minus 3, minus 4, so we have -6. That's why we end up with -6. A to the 4th remains the same. We do have two a squared terms, so -2 and positive 3 is positive 1, and that's how we end up there. Okay, now I think if I can do this right, I'm trying to find the right page. That's not the right page. Go away, page. Go away, page. Uh-oh, I think I've lost it. Ouch. Well, I don't have one. All right, let's try one. Even though I don't have one. So let's go down here, and I'll open this back up, and I'll erase this, and I'll give you an example of going ahead and substituting an expression. Yeah, there we go. I knew I could get there one day. So if I have f of x, f of x, I can't draw anymore. F of x is, let's use something simple, x squared plus 4x minus 8. Okay? And we want to find f of m plus 3. Okay? Well, we're going to that means we're going to input wherever we see an x, m plus 3 in parentheses, and that will keep the square term there, or the exponent there, 4 times, and then we'll put in our m plus 3, right? And then we'll add 8 to the backside. Now, we have to FOIL this. And when you square a term, what you do is basically square the m squared, and then you double the 3m. So it becomes 6m. And if you need to FOIL it, go ahead and FOIL it. I skipped a step because I already know what that's going to do, and then I square the outer term and I have a 9. I'm going to add to it when I distribute. 4 times m is 4m. 4 times 3 is 12. And then we're going to add 8 to that. Right? I don't have any other m squared terms, so I'm going to leave it as m squared. I do have 2 m terms, and I'm going to add them together to get 10m. And I have 9 plus 12, which is 21 plus 8. That must be 29. Okay, so that's inputting a binomial in for x. All right. Is it a little bit more complicated? Sure it is, but it happens all the time when you're talking about functions, because we're going to talk about basically almost a function within a function. All right. We're going to talk about multiplying functions later. We're going to talk about dividing functions later. All that other stuff comes with it, and it's all a good use of your algebra skill. But substitution is key. One of the last things I want to show you, I believe, if I'm not mistaken, is this. Boy, does this look scary. Does that look scary to you? So we want to talk about the behavior, the end behavior, or what an odd or even function looks like. All right? An odd function means the degree is odd, so it has a lead exponent that's odd. So if function is odd, then the degree is odd. And that makes sense because that's, just a simple line, right? A linear function. It has a degree of 1 because, y equals mx plus b. X is x to the first, so that's a straight line. And there you go. Let me get rid of that momentarily. And then if it's even, I'm losing my grip. So even, then of course the degree is even. And we know that from, f of x equals x squared plus 3x plus 2 will show us on the graph a parabola. And I was actually put it on the wrong side. Good job, dork. It goes over here. All right, and this should be at 1. It should cross at 1 and cross at 2. Okay. But that's it. And if we look at it, a linear equation points in opposite directions, be it up, be it down. One end is pointing one way, one end is pointing the other way, whereas an even function, both ends point in the same direction, be it up or be it down. All right? So we talk about it in terms of limits, right? So we say as x approaches infinity, right? As a function, so the degree is even, right? So it looks somewhat like a parabola. It may have some twists and turns along the way. It may do something like this. You know, that's quite a high degree right there with all those turns, but they both point in the same direction. So if the degree is even and the leading coefficient is positive, then it points up in the air, right? And so f of x, as x approaches negative infinity, y approaches positive infinity. And that's what that says. As x approaches negative infinity, the function approaches positive infinity. So as x goes to the left, the y is still going up. That f of x is the same thing as y, right? So the same thing holds true here. As x goes way, way, way to the right as far as it can, the y is pointing straight up, right? Well, what if this crazy function is negative? Well, if it's negative, then as x approaches negative infinity, or we keep going left for our x's, then this y value is going to get smaller and smaller and go farther and farther negative. The same thing holds true as the x value approaches positive infinity or keeps going to the right, the y value is going down. All right? So let's talk about odd functions. Odd functions are a little bit different, right? Odd functions have arrows that point in different directions, right? We just said the linear function, and I don't want to use a linear function. I want to use something a little bit different. I'll use something that looks like, let's use a positive cubic function. That's what a cubic function looks like. It has a couple of turns in it, or it just sort of turns to the right and goes back up. All right, but if you look at both ends, if this is on our coordinate plane, as we're moving left toward negative infinity, as we go on and on and on and on to the left, as x approaches negative infinity, y is also approaching negative infinity, and that's what it says right here. As x approaches negative infinity, y is also approaching negative infinity. And as x approaches positive infinity, y approaches positive infinity. I don't know why I crossed it out, but hey, you get the idea. If this happened to be a negative, and I'll just write it that way. Sometimes they look like that. I want it to be pointing outward just a little bit. This is negative, right? Because it starts higher on the left and moves down to the right. So as x moves to the left with this one, the y value keeps getting greater. It keeps going up, and vice versa. As x approaches positive infinity way out here, the y value will keep getting smaller and smaller and smaller and keep going negative. And that's really all there is to it. It's not a big deal. I'm going to get rid of this page, and we're going to analyze a couple of these graphs. All right? Well, what does it ask us to do? It says, for each graph, describe the end behavior and determine whether it represents an odd or even degree function, and state the number of real zeros. Okay? And those real zeros, believe it or not, are just simply where this graph crosses the x-axis. There's a 0, there's a 0, there's a 0. Wow. I'll tell you a secret about that a little bit later. But let's go ahead and look at number 1. Number 1, I know for a fact whether it's odd or even because I can look at the ends. If the ends are pointing in the same direction, then number 1, and we're going to do A, B, and C, right? So number 1b, we know that it's even. But describe the end behavior. The end behavior is kind of cool. F of x, and we can write it like they wrote it. F of x approaches positive infinity as x approaches negative infinity. Sorry about that infinity. And f of x approaches positive infinity as x approaches positive infinity. So this just says it goes up on both sides. Both ends go straight up, or not straight up, or up infinitely. All right, and last but certainly not least, how many real zeros are there? Well, I made 1, 2, 3, 4, 5, 6. 6 real zeros. Okay. Is everybody good with that? We had 1, 2, 3, 4, 5 turns. This, believe it or not, has a degree of 6, most likely, and because it has 5 turns, you'll learn that later. And it has all real zeros because the maximum number of zeros could possibly be the degree number. So 6 zeros. All right, and that's it. You can analyze the next one. This also is an even function, right? Because both ends are pointing downward. So this is, it has a, negative feel. So it would be as f of x approaches negative infinity as x approaches negative infinity. F of x approaches negative infinity as x approaches infinity. And then it is also an even function because the ends point the same way, and it only has one real zero because it only touches the x-axis at one place. Last, we have, this is our odd function here, right? Because the ends point in opposite directions. So we would write this one as, and I'm going to try and find another color, we would say for number 3, we would say f of x as it approaches positive infinity as not x, as x approaches negative infinity, and then f of x approaches negative infinity, it goes on downward as x approaches infinity. So this just shows that they go in opposite directions. We just said it's an odd function, odd, O-D-D. And last but certainly not least, there are 3, count them, 1, 2, and 3 zeros. 3 real zeros. 3 zeros, my heroes. And that's it. That's our lesson. Thanks for watching.